Purpose of this video is to provide some extra practice problems regarding dilutions, solution reactions, including solution stoichiometry and titrations especially. So these questions are all in your top hat, and some of them have been introduced as practice problems for actual grades. So we're going to just take a minute and go through those here. So the first one here is a dilution problem. And in this dilution problem, we are using intravenous saline, physiological saline, which is 0.155 molar sodium chloride. Now, this comes from a stock solution that is 1.5 molar sodium chloride. The question is this: what volume of standard solution do we need to make 10 liters of physiological saline? So if you recall, the dilution equation here is M1V1 is equal to M2V2. So it really doesn't matter what we set as, what conditions are 1 or what conditions are 2. What's important is that we kind of make sure that we are correct in our numbering and we remain consistent. So the standard solution is 1.5 molar. And we're asked what that volume is. So these two are going to go together on one side of the equation. It doesn't really matter which side. Traditionally, we kind of think of this as the standard side, and this is the diluted side, but the algebra is going to work the same either way. So we have 1.5 molar sodium chloride solution that we're starting with. We're trying to figure out how much we're going to need. In the end, we are going to make a 0.155 molar solution that is 10 liters in volume. So that's the other side of this equation. Now, to do the algebra, all we need to do is divide each side by 1.5 molar. That will cancel out the 1.5 molars on the left-hand side, leaving us with just V1. That'll cancel out the molarities on the other side, leaving us with liters. Now, keep in mind, you can use this equation for other volumes other than liters. You can use milliliters, nanoliters, gallons, whatever, just so long as the units are the same on both sides, because we need them to cancel out. So 0.155 times 10 divided by 1.50 to 3 significant figures would be 1.03 liters of our standard saline solution. So just as a reminder, dilution is really pretty easy and straightforward to look at. What you're ultimately doing is you are taking a concentrated substance and you're bringing it down in concentration. And so generally speaking, the two types of problems that you can do are the problems like this, where we try to figure out how much standard solution that we are going to need, or we try to figure out something about the diluted solution, like what its new volume will be, or how much of it we're going to end up making if we get this particular concentration that we're looking for. Our next example problem actually comes from one of the homework problems that I assigned you earlier on. This is one that we would have covered in lecture that day had we met. And it's along the lines of a titration. So we're told that we have 30.34 milliliters of a 0.135 molar solution of hydrochloric acid, and it's required to neutralize 25 milliliters of a sodium hydroxide solution. We want to know what the molarity of the sodium hydroxide solution is. So what we're working with here is we're working with a titration, which means it's a reaction. It's a chemical reaction. we need a balanced chemical equation. The balanced chemical equation would come from the reaction of hydrochloric acid and sodium hydroxide to give sodium chloride and water. And we can see just from looking at this, this is already a balanced equation. So our titration equation, which is very similar to the dilution equation that we just looked at, looks like this. The molarity of the acid times its volume divided by the total number of moles in the balanced chemical equation is equal to the molarity of the base times its volume divided by the total number of moles of base in the balanced chemical equation here. Since all of our values are the same, they're all 1 to 1 to 1 to 1, Na and Nb are the same as each other, and so they basically cancel out, which simplifies this equation considerably. It's now more or less a kind of weird form of the dilution equation. We just need to put, again, the right numbers in the right places. So the molarity of the hydrochloric acid is 0.135 molar. The volume is 30.34 milliliters. And again, milliliters is fine. We don't need anything more than milliliters, because if we have milliliters on the other side, it's going to cancel out anyway. And we don't know the molarity of the base, but we know that we used 25 milliliters of it. So what do I need to do? I need to divide each side by the 25 milliliters so that it cancels on that side. And only the milliliters, the unit, cancel on this side. 0.135 multiplied by 30.34 divided by 25 would give us a concentration to 3 significant figures, 0.164 molar sodium hydroxide for our base molarity. And once again, because we are dealing with a concentration of a liquid here, or of a solution rather, we need to make sure that all 3 parts are present. Is it rounded correctly? Does it have a unit, in this case molarity? And do we specify the solute? The solute in this case being the sodium hydroxide. So that is how we do these kinds of problems. And again, you can see very, very straightforward using the titration equation. Titration equation is basically just a modification of that dilution equation, just making sure that we take into consideration the stoichiometry. And once again, that should, if you see a chemical reaction, that should automatically ring kind of alarm bells in your head saying, okay, hold on, before I do anything else, do I have a balanced chemical equation? If you don't have that, then that's the fundamental thing that you're missing. That's going to make your answers very difficult to get right. Our last example problem in this video is another titration reaction. Here we are looking at the titration of apple cider vinegar, which contains acetic acid as its active ingredient, and sodium hydroxide. So the reaction that we need to set up is the reaction between sodium hydroxide and acetic acid. This is a double replacement reaction again, so we're going to get water and sodium acetate as our products here. Quick inspection of the reaction shows us that this is a 1-to-1 to 1 to 1 reaction. It's already balanced. So once again, since our acid and our base have the same coefficients, our titration equation gets simplified as follows. So to figure out the molarity of the acid, we take its volume, 25.00 milliliters, and we set that equal to the molarity of the sodium hydroxide, 1.885 molar, and its volume, 12.15 milliliters. And dividing each side by the 25.00 milliliters. We cancel out just the milliliters on the base side. 1.885 multiplied by 12.15 divided by 25. We get a molarity for the acid of 0.9161 molar acetic acid. So that's all that we're looking at here as far as titration kinds of examples are concerned. If you have further questions, please feel to reach out to me through email or through Remind. Stop me after class or show up to my office hours. I'd be glad to help you kind of get through this material and get you to the finish line here in Chapter 8. But until then, take care, and I'll see you next time.